2022, Grade 10, Cayley Math Contest, questions 21 through 25. There are exactly 4 ordered pairs of positive integers x, y that satisfy the equation 20x plus 11y is equal to 881. Mehdi writes down the 4 values of y and adds the smallest and largest of these values. What is the sum? We are essentially being asked to find integer solutions to this equation. So that's not that bad. So just make a list here, x and y, and let's see what happens. So let's just start with y equals 1. And when you plug that into this equation, you will not get an integer for x. So that's useless. And then you just keep going like that. And eventually, you'll get to 11. And 11 will give you 38. So there you go. That's our first integer solution. And then you can, you're allowed to use calculators, so you can quickly figure out that if you were to isolate one of these for one variable, this would be 881 minus 11y, and therefore x is equal to 881 minus 11y over 20. You can quickly figure out that x has to be divisible by 20, and therefore you can kind of quickly move forward to the next value of y without having to manually plug in 12, 13. And when you do, you'll get to 31, and that gives you 27. And then the next two are 51 and 16 and 71 and 5. So that's pretty much the solutions, and they want you to add the smallest and largest values of y. Okay, well, the smallest is 11 and the largest is 71. So 11 plus 71 is 82. And that is the answer to this question. And notice there's no answer choices, so you have to actually put 82 on your question paper. In the diagram, 2 circles are centered at O. The smaller circle has a radius of 1, larger radius of 3. Points P and Q are placed on the larger circle so that the areas of the 2 shaded regions are equal. If angle POQ is x, what is x? Well, a little bit of a introduction. Some of you already know this, but some of you don't, so it's good to talk about it. Let's say you have a circle, and I say to you, this is the center, and here's a pie shape. Find me the area of that pie shape, and I give you the angle. This angle in here, whatever, let's say it's 35 degrees. Okay, you would need to know the radius, so let's say the radius is 2. How you would do this is the pi area, the area of that segment, would be pi r squared times 35 degrees over 360. And 360, of course, is all the way around. So that's basically how you do it. So in this case, it would be pi times 2 squared times this fraction, whatever it is. So what we're going to do is put essentially the same formula, same system, but now to a little bit more complicated of a diagram. So they're saying that the 2 shaded areas are equal. Okay, so the first shaded area is pi r squared, this guy right here, this shaded area, pi r squared, but they told me that POQ is x, so this is x, so I don't want that pi segment, I want the complement, so it would be 360 minus x over 360. So that's that part. Okay, and that's equal to the other shaded region, which, let's use a different color. This is this guy, that whole area. Okay, so that's going to be pi big R squared times x over 360. So that's pretty straightforward. But we have to subtract that white part. So subtract from it pi small r squared x over 360. So that is, I'm pretty sure, how you would figure out this question. Okay. All right, let's proceed with this. The pi's cancel because that's in everything, and the 360s cancel because that's in everything. So all we're left with is this small r squared, which is 1 squared, 360 minus x. And then we have big R squared, which is 2 squared times x, minus small r squared, which is 1 squared times x. Oh, sorry, it was 3 squared. Yeah, big R is 3 according to this question. So this is 360 minus x is equal to 9x minus x. So that means 360 is equal to 9x, and therefore x is equal to 360 divided by 9, which is 40, right? Yeah. And that's it. Okay. So your answer to this question is 40. Andreas, Boyu, Callista, and Diane each randomly choose an integer from 1 to 9, inclusive. Each of their choices is independent of the other integers chosen, and the same integer can be chosen by more than one person. The probability that the sum of their 4 integers is even is equal to n over 6, 5, 6, 1 for some positive integer n. What is the sum of the squares of the digits of n? Okay, so let's talk about this question. We have Andreas, Boyu, Callista, and Diane. And each of them choose an integer from 1 to 9 inclusive. Okay, so each of them, it looks like, has 9 possible choices. So the probability of anything, let's write it over here, is usually a fraction, right? And the numerator is the specific condition. And that specific condition in this case is we want the sum of these numbers to be even. Okay, we'll talk about that later. But the denominator is the total. And the total in this case looks like 9 times 9 times 9 times 9, right? So that would be 9 to the power of 4. So the probability is, what's 9 to the power of 4? 6561? Yeah. And that's how they got this number here. Okay. So I guess our task is to figure out n. All right, no problem. Okay, so let's talk about n now. So n is essentially when these 4 numbers add up to an even. So for example, I'll just give you an example. Let's say you have the first person chooses, is it random or, yeah, it is random. Okay, so the first person randomly chooses a number and comes out to be a 2. This person comes out to be, let's say, 4. This person, say, 5. This person, 7. Now then you add these numbers, and let's see if this is even. 6 plus 5 is 11. 11 plus 7 is 18. So 18 is even. So this is one example. That's just an example. Okay, so that is essentially what we need to figure out is how many of these scenarios are there? And there's going to be a lot, but so we obviously cannot manually count them. So we need a system. Let's talk about everything in terms of even and odd. What scenarios are there? We can have all 4 being even, and if that is the case, then the sum will be even. We can have 3 even, not necessarily in this order, but 3 even and 1 odd. If that's the case, the sum will be odd. So that's no good. We don't want that one. We can have 2 even and 2 odd, not necessarily in this order, but 2 even, 2 odd, whatever the order is, and that sum is even. We can have 1 even and 3 odd. That sum would be odd. So that's something we don't want. Or we can have all 4 odd, and that sum is interestingly even. So we want this guy, and this guy. Okay? So I'll call this scenario 1, scenario 2, and scenario 3. And those are the 3 scenarios we need to figure out. Okay, scenario 1 is when we have all 4 even. So that means A, B, C, and D, all of them choose even. what are the even possibilities? 2, 4, 6, and 8, I believe, right? So that's 4 numbers for each of these. Yeah. So the probability of getting all 4 even would be 4 times 4 times 4 times 4. So that's 256. Not the probability, actually. It's the number. So it's 256 ways of getting all 4 even. Okay, that's pretty good. Pretty good start to this question. So now let's move forward to scenario number 2. And actually, I'm going to move forward to scenario number 3 because it's a little bit easier. Scenario number 2 is a little bit more complicated. So let's talk about 3 since it's easier. It's basically, what is it? 4 odd. Okay, so what are the odd choices? 1, 3, 5, 7, and 9, right? So that looks like 5 choices for each. So in total, that would be 5 to the power 4, which is 625. Okay, now let's turn our attention to scenario number 2. It's a little bit different because now you have to see that, yes, we have 2 even and 2 odd, but it doesn't necessarily have to be E-E-O-O, right? It could be E-E-O-O for A, B, C, D. But it also could be something like, let's say, E-O, E-O, like that. See what I mean? And that's why it's not as simple. So first, let's figure out how many different ways there are of arranging 2 even and 2 odd. Well, I got that one. How about if you put the 2 O's in the middle? That's the third one. And then let's say you have E, E, O, O. E, E over like that. And I think if you put the 2 E's at the end, yeah, I think that's it. Those are the 6 ways of doing it. Yeah. Okay. And for each, I'll just do one. This one, even, there's 4 choices, right? So 4. And then for this guy, again, 4. For this guy, it was 5, right? And for this guy, it's 5. And similarly, it would be the exact same for all the others. Yeah, it would be 4 times 4 times 5 times 5. Got it? So 4 times 4 times 5 times 5, I believe, is 16 times 25. And 16 times 25 is equal to 400. So each of these would be 400 in terms of the number of ways of doing it. And therefore, the total for these 6 would be 2400. All right. So we have to now add this guy, and this guy. So 256 plus 625 plus 2400. And that grand total is 3281. So this is the magic number that we go back and we put here, this n here. So yeah, well, they just want you to figure out n, and we did that. What did we get? 3281. Okay, great. We got n. So now what do they want? Let's just write it here. N is equal to 3281. And then they want, what is the sum of the squares of the digits of n? Okay. Well, the digits of n are 3281, so the sum of the squares would be 3 squared plus 2 squared plus 8 squared plus 1 squared. And that's what? 9 plus 4 plus 64 plus 1. And that totals 78. So this is a really nice question. Number 23, the answer would be 78. Question 24. A cube with edge length 8 is balanced on one of its vertices on a horizontal table such that the diagonal from this vertex through the interior of the cube to the farthest vertex is vertical. When the sun is directly above the top vertex, the shadow of the cube on the table is a regular hexagon. Area of this hexagon can be written in the form a square root b. What is a plus b? Well, the hardest part about this question, in my opinion, is the 3D visualization. If you have a cube with you, like a Rubik's Cube, you can, put it on a table and kind of look at it. But unfortunately, in a math contest, you probably don't have a cube with you. So in your brain, you have to figure out what this looks like. So let's put in a diagram and try to explain this. So here is a bird's eye view of what this looks like, and hopefully you'll be able to sort of kind of understand. So this is the top, this O right here is the top vertex, and that's the one that you're looking directly down on, and the sun shines in a way so that the regular hexagon is bounded by the letters A, P, B, R, C, Q. So A, P, B, R, C, Q make up that regular hexagon shadow. And they're asking you to find the area of that. Okay. And in my opinion, just to have this diagram and visualize it in your mind is the most difficult aspect of this question, because the rest of the question, to be honest, is very straightforward, and you'll see. It's really just Pythagorean theorem and the area of a triangle. Okay, so here we go. How are we going to figure out the area of this hexagon? Okay, first, if you notice that ACB is a triangle, and it's an equilateral triangle because the sides are all the same. Now, how do we know all the sides are the same? Because notice, each side is a diagonal of a face of a cube. For example, AC is the diagonal of a face, and that is the same as AB is a diagonal, and so is CB. They're all diagonals. And the diagonal of a face of a cube is essentially the diagonal of a square, and we can figure out that with Pythagoras. So for example, let's say we wanted to figure out AB. So let's say A to B, what is the length? Okay, well, the side of the square, they told me it was 8. So this is 8 and this is 8. So we can use just simple Pythagoras to figure out AB. AB squared is 8 squared plus 8 squared. So AB would be 8 root 2. Right? So there we go. That's it. So this triangle, ACB, essentially has 3 sides, each of which is 8 root 2. Now, if I draw a perpendicular like that, then that's going to split the bottom into 4 root 2 and 4 root 2, right? Because that's the property in isosceles triangles. If you drop a perpendicular, it would cut the other side in half. And then we can label this H and try to figure out H, because that is what we need to figure out the area. Again, Pythagorean theorem again, 8 squared plus 4 root 2 squared is equal to 8 root 2 squared. So 8 squared is equal to, what's that, 64 times 2, which is 128. And then this one is 2 times 16, so 32. So 8 squared is 96, so H is root 96. And root 96 is what? Something. Is it 4 root 6? Yeah, 16 times 6? Yeah, 4 root 6. Okay, I think so far so good. Now we can figure out the area of that triangle, ACB. 1/2 base times height. The base is from there to there. Let's just label it, just in case you're wondering. And the base is 8 root 2. The height is H, which we just figured out was 4 root 6. Okay, so this looks like 4 root 2 times 4 root 6, which is 16 root 12. And then that becomes 32 root 3. All right, great. Almost done. Now you say, well, okay, great. You got the triangle. You got this much of it. But what about these other guys? What about this, that, and, the other triangles? Well, those are basically mirror reflections. So let me explain. So for example, this triangle, if you flipped it, would be this triangle. This triangle, if you flipped it, would be this triangle. Like, kind of mirror reflection. And similarly, that one is that one. So if this is, say, A, that's A. If this is B, that's B. And this is C, that's C. So A plus B plus C, we just figured out was 32 root 3. So this A plus B plus C is also 32 root 3. So the total area is going to be that 32 root 3, essentially, times 2, which is 64 root 3. And that's it. We're done with the question. They're saying the area can be represented like that. So this is essentially A root B. And therefore A is 64, B is 3, and therefore A plus B, which is what they wanted, is 67. So 67 is the answer to this question. There are t tokens arranged in a circle for some positive integer t. Moving clockwise around the circle, the tokens are labeled in order with the integers from 1 to t starting from the token labeled 1. Evariste removes the token at the current position, moves clockwise to the next remaining token, moves clockwise again to the next remaining token, repeats steps 1, 2, 3 until only one token remains. When t is 337, the number on the last remaining token is L. There are other integers t for which the number on the last remaining token is also L. What are the rightmost two digits of the smallest possible value of t? Okay, so this is a question where we have to sort of just, there's no trick or magic. We just have to kind of go through it step by step. So they're saying t is 337. So 1, 2, 3, 4, 5, 6. Well, you get the point, right? I'm not going to write them all out, but dot, 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 all the way down to 335, 336, and 337. Now, these are arranged around a circle, but I'm not going to draw circles. That would be ridiculous. I'm just going to draw them, write them in a line. And initially, these numbers are all consecutive, so they differ by just 1. And you'll see why that's important. Why it's important to talk about what they differ by a little bit later on. But let's just talk about it like that. Now, let's go through this question. So what happens in this question? What is the process here? Well, you first remove the token at the current position. You start at 1 and you remove it. So if you remove it, I'm just going to circle it. Then you move to the next remaining token. Then you move again to the next remaining token. And then you remove that 1. So there you go. And that's it. You just keep doing that until you get to the very end. And if you follow this process, you'll see that you'll be removing 335 and 337. And then you will have what is remaining, which in this case is 2, 4, 6, 8, dot, 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 to 336. 334, 336. Okay, so far, there's no trick, there's no, magic, there's just simple following the instructions. Now, they differ by 2. You notice, like these guys here. Okay, let's do this again. Now, the last one we had removed was 337, right? So we then need to follow this by moving to the next one. And that would be this guy. And then we move again to the next one. And then we remove that one. And then the process continues. So then we would just continue. And then eventually we would get down to that one. So now, again, we would write down what's left, which is 2, 6, 10, 14, dot, 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 all the way to 334. And now these guys differ by 4. Okay. So now we say, okay, well, let's start this again. That was the last one I removed. So I moved to the next one, which would be a 2. And then I move to the next one, which would be 6. Then I have to remove that one. Okay. And then I would remove the 14 and so on. And then eventually I would remove the 3, 3, 4. So then you write down what's left, which would be 2, 10, 18, ... all the way to a 330. And you just have to keep extrapolating, considering the fact that they would differ by 8. You see the process here? So it just takes a little bit of thinking. It's not extremely difficult, but it is kind of time consuming, especially when you get near the end to figure out what it is that we're, what number do we get up to, and then what number do we end at, that kind of thing. Okay? So now we removed this guy, so that means we had, when we moved to the next one, it was this guy, and then we moved to the next one, it's this guy, so this we have to remove this guy. And then if you keep going down that pathway, it will eventually lead to that one being removed as well. So what's left is 2, 18, 34, ... 306, and then 322. All right? And these guys differ by 16. You see the process here. Okay, let's keep going. The last one we removed was 330. So we, sorry, I already did that one. I have to talk about this row. The last one we removed here would be 306, actually. Oh, wait. Hold on. Sorry about that. I do need to concentrate on this. The last one we removed was 330. So we moved to the 2. The next one is 18. That is what we remove. Got it. Okay, then when we keep going on that path, we would eventually remove a 306. All right. So then we write down what's left. 234, ... all the way to 322. Okay. It's like the pigs sleeping in the bed, you know, one roll over, and then there was 6 little pigs, one roll over, and then there's 5 little pigs and one roll over, and that kind of thing. All right, whatever. So we have 32 is what they differ by now. Okay. So now, since I'm so anxious to get to that 306, now I can do it. That was what was removed last. So interestingly, the next one is this guy. And then the next one is this guy. So this is what we remove now. You see, you got to be very careful. And then extrapolating, you find out that that's what you remove. And then what's left would be 34, 98.162, 226, I believe, and then 290. So there's not that many left now, and these differ by 64, and 322 is the last one removed. So this is the next one you go to, and this is the next one after that. So you'd have to remove that, and then you'd remove that. So now it's very easy. We have 34, 162, and 290 remaining. These ones are differing by 128. And then let's see, that was the last one we removed. So then when you moved over, you went to this one, and then you go to this one, and this is what you remove, and then you would remove this. So then finally we just have 162. Aha. And this is therefore your L. So hopefully I didn't confuse you too much. You were able to follow that. And that's the system, really. It's just a manual, time-consuming system. Okay, we're still not done. L is 162, which is essentially the last number remaining when you go through this process when t was equal to 337. Now, what they are saying is that there's another t that if you did this process for, you would again end up with 162 as the final number. And they want you to figure out what is that t. Now you say, well, how am I supposed to do that? I mean, what am I supposed to manually try 336 and 335 and right? And if you look at the question, they're saying that there are other integers t for which the number on the last remaining token is also L. What is the rightmost 2 digits of the smallest possible? So there's not just one other, there's several other, well, I don't know how many there are. And of all the other t's, they want you to figure out the smallest one. So very time consuming. So how do we do that? Well, what we have to do is, in my opinion, work backwards. So this process that I just did, we have to essentially do it again, but instead of going from, top to bottom, we've got to go from bottom to top, like that way, with our starting point being 162. And focusing on the fact that we want the smallest possible value of t. So that is what we're going to focus on. All right. Okay, let's see if we can do this. Now, can I keep these side by side? It'd be really helpful if I could. I'll try. The numbers might get a little small. Yeah, I think I can do it. I think I can keep them side by side. All right. Okay. Okay, here we go. So, we're going backwards, right? We're starting with the bottom. So, we're starting at this point where we are told that our L is 162. Okay. So, that is what we are basically starting with. And we got to go backwards. Okay, so we are differing at this point. No, this is our final conclusion. L is 162. So we got to go up to now this level where they differ by 128, right? Right here, differ by 128. So if they differ by 128, I want the smallest t. So I want something that is not close to 337. So I'm going to say, you know what? I'm not going to include this guy because it's too large. I want something smaller. So let's just stick with 162, and what's sort of in the vicinity. So the next one, they differ by 128, right? So 162 is definitely part of that list, but if they differ by 128, then the only other number is 34. Yeah, because I don't want to go 162 plus 128 and to get 290. The reason is because I don't want the list to be identical to what's over on this side. I want it to be smaller because I want eventually the t to be smaller than 337, and that's the only way I can see how I can do that. Okay, so far I think the system is pretty decent here, even though I haven't really done anything. Okay, now let's move forward to this step. Now they're differing by 64. So again, we're going to have to put numbers that differ by 64. So I've got the 34 in there. If I add 64 to that, I get 98. And if I add 64 to that, I get 162. Okay, that's pretty decent. Now let's go here. These ones differ by 32. So I want to make a list that differs by 32. I am going to keep the 34, the 98, and the 162, obviously. But then I've got to add numbers that differ by 32. So that means I've got to put in a 2. I've got to put in a 66, right? 130. You see what I'm doing? And then I think a couple more. 178 and let's see here. Sorry, not 178. I'm not sure why I did that. 32 plus 162, 194. Yeah. 2, 34, 66, 98, 130, 162, 194. And I've got to make sure that it's done in a way so that it's symmetric, so that every second one was removed. So this one was removed, this one, this one, and this one. And that's how I got to the next list. And then this one was removed, and that's how I got to the next list. And then this one was removed. Right? Because that process that we did all the way on the other side, that has to be maintained. Every other one has to be removed. Okay, so I think that's okay. All right, moving right along, we get to the next step here. This time they differ by 16. So it'll be 2, 18, 34, and there's going to be a lot. 162, 178, and then eventually that 194. And then same thing, I've got to make sure that they're symmetric in the way that they're removed. So in order to get this list here, that list, from the above list, I had to remove the 18 and then every second one. So I had to remove the 178 eventually, right? And then I got it. Okay, so that's correct. Okay, so let's go to the next one. That will differ by 8. So that's going to be 2, 10, 18, dot, 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 all the way to 186, 194, and then 202. And then again, let's see, I had to remove the 10 in every other one. So eventually that would have removed the 186 and 202, I believe. Right? Yeah. Okay. All right, let's keep going here. Then we're up to differing by 4. So we have 2, 6, 10, blah, 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 190, 190 something. What are we we're differing by? Yeah, 198, 202, all the way to 206 this time. And the same thing, you had to have removed the 6, and then I think the every other one, so all the way to 206. Yeah. Okay, now we're almost done. The final two. 2, 4, 6, dot, 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 all the way to 204, 206, and then 208. Because again, you're removing every other one, the 4, dot, 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 and you'd be removing 204 and 208. And the final one, let's use a different color. These ones are going to differ by 1. So it'd be 1, 2, 3, all the way till 207, 208, and 209. Yeah, because you'd remove 207 and 209 in order to get to the next row. And that's it. So 209 is the final number in that original list, and therefore in this case T was 209. And they want the last 2 digits for some reason, so they want you to just put down 09. So that is it. And just one final, I guess, conclusion I'd write is that the pattern shows that we must have at least 209 tokens for the final token to be 162. So since that is true, T equals 209 is the smallest possible value of T. So this is therefore the smallest possible value, and that's how we can conclude that this is the answer, because they want the last 2 digits.